everyone, welcome back again. Today we'll be solving question based on triangles. Now the first question is, in triangle ABC and triangle DEF, where we have AB which is equal to DE, BC which is equal to DF, and angle A which is equal to angle D. Now which of the following holds correct congruence axiom for these two triangles? Now let us draw the figure for these two triangles. This is triangle A, B and C. Then we have triangle D, E and F. Now we have AB which is equal to DE. Then we have BC which is equal to DF, and angle A which is equal to angle D. Now if we were to look into the figures, in these two figures we are considering two sides and an angle. Two sides and an angle. If you see the option B and option C, we have been given two angles and a sides. Two angles and a side. So we are going to discard these two options. Now for side angle side, if two triangles were to be congruent by side angle side, then we are going to have common angle between the two sides. Now here we are having two sides and angle D which is common, but angle A is not common here. Angle A is not common between the two sides AB and BC. Instead of angle A, we were the common angle should have been angle B. Then only these two triangles were congruent by side angle side. So the option D is the right answer, where these two triangles are not congruent to each other. Fine. Let us look into the next question, where we have triangle ABC and triangle PQR, where AB which is equal to AC, angle C which is equal to angle P, and angle B which is equal to angle Q. Now for these two triangles, we have to check and find out whether they are isosceles, congruent, or both. Now firstly we are going to draw the diagram for these two triangles. This is triangle A, B and C. Then we have triangle PQR. Now we've been given AB is equal to AC. Now when AB is equal to AC, that means angle B is equal to angle C. Angle B is equal to angle C, base angles of isosceles triangle. Now if you look into this part of the question, where we have angle C which is equal to angle P, what can we conclude from these two equations? That angle C is equal to angle B which is equal to angle P. Now here we have angle B which is equal to angle Q. That means angle C is equal to angle B which is equal to angle P, which again is equal to angle Q. That means all these four angles are equal. Angle B, angle C, angle Q and angle P are equal. That means PR is equal to QR. So these two triangles, they are isosceles triangles, but they are not congruent. Isosceles but not congruent. So the option A is the right answer. Great. In the next question, we are having triangle ABC, where AB is equal to AC, OB is equal to OC. Now we have to find the ratio of angle ABO and angle ACO. As the triangle ABC has AB is equal to AC, that means angle B is equal to angle C. That is the base angle of isosceles triangle. Let us suppose these two angles is equal to angle X. Now let us consider triangle BOC. Now which is again having OB equal to OC. So this angle and this angle are equal. Again base angles of an isosceles triangles. Now suppose this angle is A, this angle is also going to be A. Now what is going to be the value of these two angles? This is going to be x minus a, and here also I'm going to get x minus a. So the ratio of these two angles is going to be x upon x minus a upon x minus a. Cancels out, 1:1. So the option A is the right answer. Let's see the next question, where we've been given the bisector of angle A of a triangle ABC meeting BC at D such that AD is perpendicular to BC, and the values of AB, BD, BC and AC is given. We have to calculate the value of x and y. So first what we're going to do is we're going to draw the required triangle. Now this is triangle ABC. Now the question reads the bisector of angle A. So this is the bisector of angle A. That means this angle and this angle are equal, meeting BC at point D such that AD is perpendicular to BC. That means both these angles measure 90 degree. Now let us consider the triangle ADB and triangle ADC. Now here angle A is equal to angle A, bisector of angle A. Then we have AD and AD, the common side, and then we have angle ADB equal to angle ADC. So what can we conclude from this? We can conclude that the triangle ADB is congruent to triangle ADC, and that is by angle, side angle, axiom of congruency. Now what happens? D becomes the midpoint of BC, that is by CPCT. This side and this side becomes equal. Now we have labeled the sides with their respective dimensions. Now here we have to calculate the value of CD. Now CD is going to be 3x plus 2y minus 1 minus 3x plus 1. So 3x plus 2y minus 1 minus 3x minus 1. Plus and minus gets cancelled. So the value of CD is going to be 2y minus 2. Now we know that the triangle ABD and triangle ACD are congruent to each other. That means the side AB is going to be equal to AC. That is going to be by CPCT. And D is the midpoint, and therefore BD is going to be equal to DC again by CPCT. Okay, let us consider the first case where AB is equal to AC. That means 2x plus y, which is equal to 8x minus y. If we were to solve this equation further, we are going to get 3x minus y, which is equal to 0. Now this is a first equation. And in the second case where BD is equal to DC, we are going to get 3x plus 1, which is equal to 2y minus 2. Solving it further, we are going to get the second equation as 3x minus 2y, which is equal to minus 3. And this is a second equation. Now we are going to solve for these two simultaneous equations. We are going to get the value of x as 1 and the value of y as 3. Now seeing the option B is the correct answer.